Alright, hi guys, Eric here at Redmans Performance. It's going to be part 2 of the Toyota 22RE assembly steps. So what we're going to do today, we're going to install the crankshaft here. I'm going to go over how I install the main bearing shell, install the caps, how I torque them, and the assembly lube that I use. So the assembly lube that I always use is MAXIMA assembly grease. You guys can see that. See if I can read the part number. Part number is a 69-02901. These are a little 1 ounce tube. I prefer these 1 ounce tubes over a tub of grease. The reason why I like the little 1 ounce tubes, they're single use. One tube will get you through a motor. The grease never gets contaminated. Grease sitting around on your bench gets contaminations in it, whether it's microscopic particles and or grit or machine shavings that are floating around in the shop. Maybe somebody comes and grabs your brush, uses it, there's debris on it, he sticks it back in. Now you've got a contaminated bearing in a brand new motor. So it's really important to use clean grease, same as clean crankshafts. Now, I've already mic'd the crankshaft, checked the bearings for sizes. So that's already been done. That's something that you guys are going to need to do on your end before assembly. We're just going to go over the installation process here. So here we go. So, two things about bearings here. Myself personally, I try to never ever touch the bearing itself with my bare hand. We have acids in our fingers. If you touch this bearing when you have sweat on your fingers, the acids will actually give you an erosion line in that bearing. Now they might not do it today, it might take a day, it might take 2 days, just kind of depending upon the amount of humidity in the air that day. So, the way that we install the bearings though in the block on this, there's always two styles of bearings. There's an upper and there's a lower. So the upper is the block side and the lower would be what would be the main bearing cap side. So on this one, the upper bearing, you can see there has a hole in it. So you always want to make sure that the holes line up with the holes. Also there is a bearing tang or a bearing lock, whatever you guys want to call it. I preferably call them a bearing tang. So we're going to install the bearings inside the crank now. So let's see if we can get you guys a better picture here now. It's kind of hard to do the filming and everything at one time. So, you guys can see there on the bench, I've already got all of my uppers and my lower bearings laid out. Makes it a little bit easier for me. When I set the bearings down inside the block here, I push in on the side of the bearing to make sure that it's level with the cap, or the reference. So now, this next part is probably one of the parts that most novice engine builders and or entry-level builders do. And they use too much grease in my opinion. So you don't need to use a lot of grease. If you use too much grease, depending on how cold it is, or mainly cold, heat doesn't affect it as bad. It'll cause your crank to give you an inaccurate read on the way it feels. That's another reason why I like the MAXIMA grease. It doesn't give me an inaccurate read on the rotating torque when we're done. And I'll show you how I check the resistance of the crankshaft when I'm done here. This crank should probably end up somewhere probably 2.5 to 3.5 pounds of rotational drag on it. The thrust in play on this crank, Toyota calls for 8/10 to, I believe, 8 7/10. What I would like to see is I'd like to see somewhere in maybe 2 8/10 to probably 3 1/2, somewhere in that area. So on the grease, what we're going to do is, the nice thing about this is you just cut the end off, whatever size you like. I cut it off right where they kind of reference it. I'll put 3 dabs of grease on each bearing shell, about the size of a pea. I'll do one on each side, one in the bottom, And then that's how I'll grease this crankshaft. So at that point in time, we'll grab the crank and we'll set the crank in there. Well, actually not, because I forgot the thrust bearing. So, next thing here is thrust bearings. So thrust bearings always seem to want to fall out of the crankshaft when you put them in. So there's a side here that has a couple grooves cut into it. The grooves always go towards the crankshaft. And the flat side, which is this side right here, goes into the block. So what I'm going to do is I'm going to put a very slight amount of grease on this. You can see the only thing I'm going to use this for is to cause a vacuum on the block, so then that'll help retain this thrust washer. So on this one, the way that you'll decipher the upper and the lower thrust is the upper thrust is round, and then the main cap side actually has a little notch on it, or you can see. So anyway, again, just a little bit of grease, just enough to cause a vacuum. Then what I'll do is I'll put about the same amount of grease on the inside of the thrust, portion that will hit the crankshaft. Try to always use white paper towels when you guys are building your engines. Try not to ever use shop rags, or maybe an old leftover towel that you ran through the laundry. The problem with an old leftover towel that you ran through the laundry, it has lint and fuzz on it. These towels, they don't have lint to them, and they're clean. Where if you get a shop towel, the problem with a shop towel is the shop towel always has oil in it, so it is a big, big problem. So you just do not want, you absolutely do not want to use the shop rags or linen cloths anyway. So now we'll set the crankshaft down inside the engine. Alright, so now we're going to get ready to do the main caps. So the mains are already laid out in order. Everything that I do when I build an engine, I lay everything out in order. It just kind of helps me flow along here. It makes things easier for me. The extra 5 or 10 minutes that it takes to get all my preparation work done. And that way I know that I've inspected everything. So, here's the main cap side. You can see about that much grease there. So this particular cap has an arrow on it that tells you that it's going towards the front of the engine. About 90% of all engines built, the bearing lock goes to the bearing lock. LS is one of the ones that does not do that. I've got another video that will show you guys how the LS main caps go together. Number 5, now we'll get number 4. Always try to hand start your bolts, 2 or 3 threads. Don't just get onto them with a gun and start them. You take a chance of cross-threading a bolt. If you cross-thread a bolt, now you got to stop, clean everything, take it all back apart, and probably do some thread repair. Or possibly even junk the block that's already been bored, hung, decked. Maybe had $400, $500, $600, maybe more, where the machine would have done to it. So on this same one, we're going to put just a little bit of grease here on the cap, because this one's easy for me to get to the cap on. Put the serrations on the thrust washers out. A little bit of grease on the external side of the thrust washer. Roll it over. Put some grease on the other one. Lay the thrust washer on it. A little bit of grease on that thrust washer on the external side also. Put the main bearing cap on there. And hand start the bolts. Excuse me. So every time you can see I'm running about the same consistency for grease. So I use a little lightweight 9.6 gun for running the bolts down. No reason to use a half-inch gun or a big old air gun. If you only have a half-inch gun or an air gun, I recommend doing this by hand. Alright, so now what we're going to do is now we're going to torque the main caps. We already know that the mains turn, or the crankshaft turns inside the mains, so we know that we don't have a bearing too tight. And we kind of already know that anyway because I did all the pre-work on this by micing and clearance and everything before we got to this point. For you guys that don't have mics, maybe try plastic gauge, or hopefully you're using a good machine shop that does that for you. Alright, so what I do is all the engines that I build, I data log or log all the bolts that I torque and what I torque them at. So I'm going to give you guys the pattern that I use. Hopefully you guys can see this. What I'll do is it says main torque, passenger side and driver side. This one has the 5 mains on it. So I've got passenger side 1 through 5, driver side 1 through 5. So for every bolt that I torque, what I'll do is I'll write down that torque value. That way, customer calls me back a year from now, says, hey, what did you torque that bolt at? I'll be able to go to the file, pull the thumb drive out, put it in the computer, and tell us anything that we need to know on this motor. To this point right here, I've already got a running list of the freeze plugs, how many oil gallery plugs I've used in it, the thrust washers, and the main bearings. And as we go on, it'll tell me the brands, the sizing, and everything else that we're using in it. So the mains on this one torque at 76 pounds. So I'm not going to go straight to 76 pounds. I'm going to get in there about halfway. So I'm going to get into about the mid 45 range to begin with. One good thing about the digital wrench like this is you can watch the scale crawl. So you don't necessarily have to set your torque on it when you're just trying to hit a half scale like this. Alright, crank still turns fine. So now what we're going to do is now we're going to actually torque. So that one was 76.6 pounds. $76.4. So we're going to write those down. $76 pounds even. $76.1. $76.5. 76.1. $76.5, $76.3. 76.6. $76.2. Okay, so there's two reasons why we want to use this book and write these numbers down. One is that way later we know what we did on this engine. Secondly, this ensures that you torque every bolt. So this right here just helps keep us honest, or you honest, whoever's doing the job. I would like to think anybody that has taken the time to torque the bolt and write that number down is not lying to somebody about it, that they're being honest about what they're doing in their figures. So every job before I start, I have a calibrator for my torque wrenches, and I recalibrate my wrench, or at least check the calibration on it. If it's calibrated, then I go ahead and use it. If it's not, I take the time to recalibrate the wrench. So now what I'm going to do is I'm going to show you guys how I check the resistance of the crankshaft, and then we're going to check the thrust in play to make sure that we're inside the window that Toyota recommends for. And then we're going to log that also. So I'm going to show you guys this. So this is a turner with a square drive in it, some keyways in it. Most people are probably not going to have this, so you guys can use a bolt in the end of your crankshaft. That'll work just plenty fine. This will slide up on the keyway. I'll take the Allen, tighten it down. Now what I'm going to do is I'm actually going to go to my 1/4 inch torque wrench, because it's my lowest valued torque wrench. This thing will drop down to 1 pound. So, remember I said about 2.5 to 3.5 pounds is what I was looking for. I'm going to do 1 revolution. Got 2.84 pounds. So let's do it again. Second time I got 3.21 pounds. I don't know if you guys can see that or not. 3.21. So maybe I got into the wrench just a little heavier to begin with than I did the first time. But I know that the resistance on that crankshaft is right where I want it to be. This is another tool that tells you that your crankshafts are not too tight. It's a huge tool that needs to be used when you're assembling motors used for crankshafts. It does not just have to be used to torque a bolt. So now let's do the end play on the crankshaft. Alright, so what did we say? 8.7 is what Toyota wanted. 0.8 to 8.7 is what Toyota wanted. So, told you guys that I'd like to see somewhere right around 3. Let's see where I end up. I like using this 2-inch dial for doing this. Normally it lets me get around the snout on the crankshaft well. Anyway, we've got a neutral buoyancy on the crankshaft, and I got it set to 0. So I get a pry bore, like anybody else was going to have to use here. I'm going to go ahead and pry this crank forward a little bit, and I'm going to re-zero this gauge. I'm not putting too much pressure on it, I'm just putting probably about 10 or 15 pounds would be my guess. Now I'm going to go back with it. Let me get a better view so I can see it. 3.5 thousandths is what we're getting. So at 3.5 thousandths, we know we're inside the factory window, but the bigger thing is we know that we're exactly where I want to be. And as a professional builder, there's a lot of times that I don't necessarily do what the book calls for. Maybe we clearance a little bigger, maybe we clearance a little tighter, depending upon what the guy is doing with the engine, what application is being used in. So if there's any questions that you guys have, please feel free to ask. I'd be more than happy to answer them. Lubrications, the grease, that is the absolute best assembly grease that I've ever found. I've been building motors for 40 plus years now. I've done tens of thousands of them. Tried about every assembly grease known to man. That is absolutely the best stuff I've ever found. We believe in it so much here. When we do an engine kit out the door, if the customer does not use the break-in oils and the assembly greases that we recommend, we will not warranty the job. That's how much we believe in the products that we use. So check out the assembly grease. It's a good thing. Make sure to get the single uses also. It's a huge part of it. That way you don't get contamination. When you're done with this engine, just throw the little bit extra left away. It's not a big deal. It's going to cost you a few pennies just to throw that little bit out. And you're not going to contaminate your next build. Anyway, please hit the like and subscribe button. Thank you for watching Eric at Redmans Performance.